level 4, this is higher order. So we're trying to figure out how to factor higher order polynomials. So higher order is anything bigger than x squared. X squared we talked about, that was the quadratics. So this is greater than x squared. That's what we mean by higher order. Actually not equal to, just greater than. So the rules for doing this are, first, put it in standard form, descending order. Make sure that it's in that form. That's the easiest way. We have to have that set up like that. Then we factor out a GCF. This is why it's higher order, because you're doing multiple steps to do this. And then we're going to use one of these 3 methods. You have to be able to do 3 of these to get a 3. You have to be able to do all of those to get a 3. So pay attention, make sure that even if you don't want to go for the 4, that you're at least paying attention and can see how this goes in order. And the way that we can tell that we're done factored, if it's completely factored, none of the factors, so those things that are in parentheses, none of the factors can still be broken down. So I can't keep going. There's no 2 and a 4. There's no x squared and a 36. Like, it can't keep going. So when we look at this first one, that's the reason this is higher order. That's not squared, obviously. So this is what makes it a higher order. This is what makes it a higher order. But we're still going to go through the same steps. Remember that I said that you take the square root of both sides. So I need the square root of x4 and the square root of 36. There is an imaginary 2 out here when it's a square root. We don't write it. But what you do when you take the square root of a number is you divide the exponents. So this becomes x squared, and this becomes 6. So we write our parentheses, and it's x squared minus 6, x squared plus 6. And that can't be broken down anymore because 6 is not a perfect square. All right, so let's look at this one. So this, when we do square roots, obviously it's best to have an even power because I'm going to divide those. I'm going to divide by 2. So that's not an even power, but there is an x in both things. So I can divide a greatest common factor of 9x. So I can divide these both by 9x so that I get 9x times x to the 4th minus 16. These are perfect squares. That's a perfect square. So then I can bring the 9x down here. And when I take the square root of x to the 4th, that's x squared. And the square root of 16 is 4. So then we get x squared minus 4, x squared plus 4. But what is this? This is also a perfect square. So I got to do it again. So then we take 9x times x squared minus 4, x squared plus 4. And we take the square root of x squared and the square root of 4 so that I get x and 2. And that's 9x times x minus 2, x plus 2, x squared plus 4. So that has 3 steps. You have to factor out a greatest common factor. You have to take care of a perfect square once. And you have to make sure that you don't have another one to keep going. This isn't hard. It just requires that you pay attention and look for multiple things to do in the problem. So when we look at this, I need to factor. There's no common factors yet, but if I do grouping, if I can break it up into grouping, so we're going to do the AC method first. So AC is 3 times negative 5, so that's negative 15, and it needs to add to be 14. So the factors of 15, that's negative 1 and 15, and negative 3 and 5. So this is the pair that works. So I'm going to break this down into negative x plus 15x. So I have 3x to the 4th minus, sorry, it's x squared, minus x squared plus 15x squared minus 5. I can divide this one by x squared, and I can divide this one by 5. So I have x squared times 3x squared minus 1, and plus 5 times 3x squared minus 1. So we get x squared plus 5, 3x minus 1. I know that I'm done because I can't do anything with this. This doesn't go any further, and even though this is a squared, 5 is not, so then I have to be finished. So that's my final answer. So we're going to start with the AC method. That's 1 times 18, that's 18. And I need it to equal negative 11. So that's negative 1 and negative 18 to get positive 18. And a negative 2 and negative 9 and negative 3 and negative 6. The ones that equal 11 are the negative 2 and the negative 9. So we're going to rewrite this as negative 2x squared, negative 9x squared. So I have x to the 4th minus 2x squared minus 9x squared plus 18. I can divide this by x squared. And I can divide this by negative 9. So I have x squared times x squared minus 2 minus 9 times x squared minus 2. So I have x squared minus 9, x squared minus 2. But we're not done. Why not? That's a perfect square. So now I have to say, okay, well then I need to take the square root of x squared and the square root of 9 so that we get x and 3. So I get x minus 3, x plus 3, x squared minus 2. And that is the final answer. So even though this is a combination and you are doing lots of steps, hopefully as you're following along, you can see the single process. So how to use the AC method, how to do the grouping method, how to do this perfect square method. So even though we're doing it all together, hopefully you can see how to do it separately as well. Yeah. All right. So let's look at this one. Why didn't I look for a GCF here? Because there's nothing that 3, 14, and 5 divide into. The same thing with 1, 11, and 18. But here, I can divide all those by 5. So first, we're going to do a GCF of 5. So I have 5 times x to the 4th minus 2x squared minus 63. And now I'm going to do the AC method, which is I needed to multiply to be negative 63. I needed to add to be negative 2. So that's negative or positive 7 and negative 9. So negative 7x squared, positive 7x squared minus 9x squared. So that's 5 times x to the 4th plus 7x squared minus 9x squared minus 63. Can divide this by x squared, divide this by negative 9. So I have x squared times x squared plus 7 minus 9 times x squared plus 7. That's 5 times x squared minus 9, x squared plus 7. Now what? This is a perfect square. So that when I'm finished, I have 5 times x minus 3, x plus 3, x squared plus 7. What can I divide all of those terms by? 3x. So my GCF is 3x. My greatest common factor is 3x. So that gives me 3x times x to the 4th minus 3x squared minus 28. Now I need to multiply to be negative 28 and add to be negative 3. So that's positive 4 and negative 7. So plus 4x squared minus 7x squared. So I have 3x times x to the 4th plus 4x squared minus 7x squared minus 28. Divide by x squared divide by -7. 3x times x squared minus 7 times x squared plus 4. Am I done? Can I do, this is a square, where'd it go? This is a square and this is a square. Can I do anything with this x squared plus 4? No, because this is an addition sign. This has to be negative for us to do anything with it, to continue to factor it, so that's the end. So I want you to notice that the first thing that we did in all of these was look for a GCF. And then we did the AC method, and then we did grouping. So it seems so far to be GCF, then AC, then grouping, and then difference of squares. That seems to be the order that is the most effective in solving these or factoring these. When you look at number 7, there's already 4 terms, so I'm probably going to need to do grouping for sure. AC only works with 3 terms. Grouping is better for 4. And so it's already in 4, so I want to try to break it down. I can divide both of these by x squared, and I can divide both of these by -4. So I have x squared, x to the third plus 5 minus 4 times x to the third plus 5. So I have x squared minus 4. X to the third plus 5. So I did a GCF. No, I didn't. I did the grouping by doing this. So now I need to look for difference of squares, and I have one right here. So this becomes x minus 2, x plus 2, x cubed plus 5. All right, so where do we start? We have this one. We're going to start with our list. I'm going to look for a GCF. Those are all even numbers, so I can divide. They don't all have x's, so I'm just going to divide by 2. So we do a GCF of 2, which is 2 times x to the 5th plus 2x squared minus 16x cubed minus 32. Now we're going to try to do grouping. So I'm going to divide by x squared for these two and divide by -16 for these two. So I have 2 times x squared minus 16, x3 plus 2. So we've done the grouping. Now I need to recognize that this is a perfect square. So this becomes 2 times x minus 4, x plus 4, x cubed plus 2. So I would somewhere keep that with you, maybe on the back of your blue card, so that you can keep track of what to do in order when you have multiple things to do. And make sure that you can do each individual piece as well as more complicated ones.